Hello and welcome back everyone. For a while now I've wanted to improve the spray and mist coolant setups I made some time ago for the mill in the Colchester. The system I'll be building for the mill will be a mist system. That is, the coolant will be drawn from the storage tank to the spray head by a venturi. The system for the Colchester will be spray configuration. In this system, the coolant will be pressurised in the storage tank and pushed to the spray head under pressure. These two systems are configured differently and dissimilar in their delivery of coolant. They will both complement the built-in Flood Coolant systems already installed on these machines. Like the mill, the Toolmaster also has a very nice Flood Coolant system. I plan to install a spray system to complement that at a later date. G'day, I'm Steve-O and welcome to the Outback Shed. In planning for the mill system, I came across this offering on eBay. There are 24, 110 and 22 volt options. I picked a 220 volt unit with a double spray head as that was the only option available. A 24 volt option would be able to be connected directly to the mill electrical system, but I don't want to connect anything additional or alter the system in any way. A fully standalone installation is how I wish to proceed. I ordered two systems and they arrived a few days later. Let's unbox it and see what we got. There's a 220 volt air solenoid with all of the required air fittings. I would prefer not to have a 220 volt electrical circuit and switch on my machines, so I'll be replacing the electrical solenoids with lever action manually operated valves. Some air and coolant tubing to suit the installation, a 3 litre coolant tank with a dip tube and check valve including both 4mm and 8mm splitters to cater for two spray heads. There's a regulator with a pressure gauge and mounting bracket and more air fittings. Lastly, there are two spray heads. They look similar in appearance to a Noga, but they don't have the adjustable on-off knob. If I bought the parts separately, the regulator would be around $90, the solenoid would be between $100 and $300 depending on the brand. The spray heads would be around $35 each on eBay, plus around $20 for tubing and $20 for the fittings and plus the tank. So I reckon I got more than $300 worth of kit from the $85. Let's start with a brief description of the various coolant delivery systems. Flood is the most common and widely used coolant system. A pump delivers coolant through a pipe to a flexible delivery tube pointed at the workpiece. A tap or valve is used to regulate the flow. The delivery spout may have different sizing options depending on the brand and delivery of the pipe. A containment and plumbing system that allows for return of the used coolant to the machine coolant tank is essential. Most freestanding lathes or those mounted on a stand or plinth have recirculating flood coolant systems pre-installed. If they don't, it's generally not that difficult to install one. The Mist system uses air as a propellant to atomize the coolant into a fluid stream. Coolant will be stored in the 3 litre tank that came with the kit, mounted at a distance close to the spray head and of similar height. The coolant is drawn to the spray head by the low pressure created by the air passing through a venturi in the spray head. Having the tank at a similar but lower height than the venturi will minimize the head of vacuum needed to draw the coolant from the tank to the spray head. Having it higher may induce a siphon effect. The venturi has a reduced diameter in the airline at the point of the coolant inlet. This forces the airstream to increase in speed at that point and creates a low pressure area to draw the coolant from the tank to the spray head. This provides a spray of air with coolant in a finely atomized state. The coolant droplets are small and there is a propensity for fogging and creation of clouds, which are undesirable due to the toxicity of airborne coolant, and it tends to settle everywhere, resulting in unacceptable mess. For those reasons, very low pressure is how I will use this system. For the spray system, I'll use a water filter housing, and I already have one installed from a previous build, which never really worked. Again, I'll use the manual air switch and not the electric solenoid. The regulated air pressurizes the coolant in the filter housing and has a bypass air line to the spray head. This has a big effect on the atomization of the coolant, as it is delivered to the spray head under positive pressure and not under low vacuum. This causes the coolant to atomize into much larger droplets and form a spray rather than a mist. The upside of this is that the spray head can deliver any ratio of air and coolant mix from 100% air to 100% coolant, which is essentially flood coolant. This design is based on others that have already been built and shown on YouTube. 2 builds that come to mind are by Tom Lipton at Ox Tools and Rob from Dudley Toolright. I'll put links to their videos in the description. I'll build the mill system first. The mounting will be installed on the head next to the spindle, utilising an existing mount for the cutter guard, which I'm not currently using. I'm machining a piece of 304 stainless to make the shaft. I machined this in 2 bites to avoid installing the travelling steady. Not standard practice, but for one small job, it worked fine. I'm using a TNGG insert and it's producing a terrible swarf. Long, stringy and dangerous. I don't think I'll use this insert on 304 again anytime soon. I previously built a spray coolant system for my BM62 mill. I used a water filter housing and plumbed in the same way as I will for this installation. This install also used a water filter housing. Shed air is fed from the manifold to the filter housing through a regulator. There's a T-joint between the regulator and the housing to take off the bypass air. Both the bypass air and the coolant are connected to a quick disconnect block. This allows the removal of the spray head and mixer when not in use. There are several isolation and flow adjustment points, including a master on the hose that shuts off both air and coolant to shut off the system and preserve the settings. Well, that was the plan. However, the mixer I made didn't really work as I would have liked. It tended to surge with heavy and light patches of coolant in the airstream. I could have used a Noga spray head as per Tom's design. The Noga spray head are a little hard to find and are very expensive here. The spray head from the eBay kit would be fine to attach to this system. This cap fits on a pop or water bottle, and the barb can be used to connect a plastic dip tube. The quick disconnect system that I used on that build is commonly found on homebrew beer kegs. There are 2 types, one for gas and one for liquid. The only differences are the connection diameters. Grey for gas and black for liquid. They're not expensive at around $10 a fitting, and I'll put links to them in the description for anybody interested in using them. Ask me how I know that. I cut the connector off at the top and mounted it into an aluminium block with a press fit brass plug. This has an O-ring to seal against the inside of the bottleneck. This block is based on Tom Lipton's design. The block has a pass-through for the air bypass. The fittings have holes for air to pressurise the bottle and to install a dip tube for coolant outlet. A bottle just screws into the 5/8 BSP female thread in the cap. No need to cut a special thread to fit the bottle. I just couldn't get my head around having a pop bottle hanging off the side of my mill, so I went with the water cooler housing instead, and it only cost $20. For this build on the new mill, I installed a regulator and tank and ran the tubing. The tank has a sticker on the front which I'll remove and install my own stickers after cleaning off with isopropyl alcohol. The call-outs show the sticker and the translation. I'll put a piece of masking tape on the side to measure the volume so I can make a better volume scale. I'll be using Hangsdorfer's 5080 at the recommended 10% concentration. I already have a cube made up as I'm using that for flood coolant in other machines. I'll fill the tank in 500mm increments and note the volume on the tape. I can then print a level indicator and some graphics to suit. The tank is supposed to hold 3 litres, and I guess if filled to the top it would, but 2.5 litres will be enough capacity for my needs. The spray head is nicely made and has brass adjusters with lock nuts for both air and coolant. The flexible delivery pipe has a small tube running through it from the coolant input to the brass tip, which is where the venturi is. This is the point where atomization occurs. The 220-volt solenoid is an electrically operated switch. When de-energized, it allows passage of air through the top port. When the internal coil is energized, it closes that port and opens the lower port. Any remaining air on the top port is vented through the air exhaust. This allows the solenoid to operate both as an on-off switch or as a directional switch to open and close a pneumatic cylinder ram. This requires 240-volt electrical trigger to make it work, but I would prefer not to have an electrical switch on the machine, so I'll be replacing this with a manual toggle operated air valve. It's the same as the electrically operated solenoid, only it has a manual toggle switch and not an electrical trigger. Air enters here and exits there. This is normally off and this is the on position. The top port is blanked off as the off position is not used. This is the silencer on the exhaust port for the on position, so that when the lever is moved to the off position, the air exhausts through this port. This costs $100 and it's a far better option than the electrical solenoid. I made up a backing plate off camera. Not much to see there, just drilling a few holes and bedding a piece of 2mm steel sheet. I'll assemble the parts using stainless hex hardware. Regulated air in here, and the air pipe connects the switched outlet directly to the spray head air input, and the unit is ready to mount on the mill. The mounting rod is long enough to allow the assembly to tuck away when not in use and to slide to a low position when I need. It has a cap to prevent it coming off during use. Walking through the system, shed air is supplied to the mill air manifold, which I built in a previous project, and it has takeoffs in both the air draw bar and the Mist Coolant System, both of which have their own isolation taps so I can pressurize only what I want to use. I replaced the high pressure air gauge that came with the regulator for a low pressure gauge that has a maximum of 35 psi. This makes setting and reading lower pressures easily readable and more accurate. The plumbing is very simple, and it has additional length to cater for occasions when I might want to extend the ram forward. I did the initial setup at 30 psi. It tended to mist and create some fog, so I wound the pressure back to zero and increased it to a point that I was happy with. I settled on 7.5 psi, and that seemed about right. That's working better with no visible fog. To be clear, I don't want a lot of air or coolant from the system, just a gentle breeze and a damp surface. If I want a lot of coolant, I can use the flood system. I tested the system while machining the mounting block for the Colchester Spray head. Already I can see that the surface is wet and that the swarf is tending to form clumps rather than fly off the cutter. There's a visible coolant film on the workpiece and the airstream is not strong enough to blow the swarf away. I'm very happy with that. Some experimentation will be needed to optimize the settings for different cuts and on different materials. When I choose to use coolant, I will likely use this for brass and aluminium and for fly cutting steel. For heavy machining on steel, I'll likely use the Flood Coolant. Although these were very light cuts at 0.5 mm depth, there is no build-up of swarf on the end mill cutting edges. The light cuts were because I could only hold the aluminium block by a small amount. For Colchester, I already have water filtering housing installed from a previous project that was also unsuccessful. I just need to alter the plumbing and install a new spray head. Again, this is a simple build which I mostly did off camera, just drilling some holes and another piece of 2 mm steel sheet. I've mounted the regulator together with a toggle switch as I need to pressurize the tank at the same level as the air supply to the spray head. The spray head is mounted on a magnetic base from a dial indicator stand and uses the bracket I machined on the mill. It sits out of the way at the back of the bed when not in use. It can be mounted to either the top or compound slides and the nozzle will track with the cutting tool, or it can be mounted on the bed or saddle if a static position is needed. I have the air set at 10 psi when it's in use. With the air off, it can deliver 100% coolant. With only the air on and the coolant off, I can use the airstream to influence the movement of swarf around the tool bit. Letting the coolant in, I can set the desired mix and pressures to provide a coolant spray with minimal mist and no fog. Again, I'm looking for a gentle breeze with a damp surface. I'm running the lathe at 210 RPM with a 130mm diameter piece of aluminium. It's cutting well and making minimal mess. Some swarf is sticking to the workpiece, and when stopped you can see coolant droplets. Well, it didn't use a lot of coolant. Walking through the setup. The shed air has an isolation tap and then goes to the input side of the regulator, then out from the regulator to the inlet side of the toggle valve. The low pressure air from the outlet is then connected to pressurize the coolant tank. A connector takes bypass air directly to the spray head, while the pressure in the tank delivers coolant at the regulated pressure to the spray head. I'm very happy with the finished builds, and we'll see how they perform in future projects. Conclusions. I jotted down a few bullet points on what I see as the main descriptions, advantages and disadvantages of each system. I won't speak to each point, but you can pause the video and read them in detail if you like. I will stress that these are my observations from my shed using my equipment and learnings from other YouTube videos. I'm not quoting theory or textbooks. You may agree or disagree with my observations, but this is how I see the system set up and functioning. If you're looking to install coolant, the type of system you install will depend on your circumstances and how you want to use coolant on your machines. One thing is for sure, I will be using a respirator with both systems and keeping a very close eye for any overspray or coolant coatings on any surfaces. If you have different observations or views on coolants, I will be interested to hear them, so please feel free to leave me a comment. Well, that's it for now. If you've made it all the way through to the end, I really appreciate it, and I hope you enjoyed the video. Please give this video a like and subscribe to my channel if you haven't already. As always, thanks for watching. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.